And from there, I told you the difference between an ideal gas and a real gas. A gas that obeys all gas laws is said to be ideal, said to be real. And we said there is no gas that is actually ideal in nature, Abby. So most gases we have are said to be real gases. Because the moment you change condition, they will condense, they will even solidify. If you take CO2 for example, CO2 can solidify, and that is why you have it in your fire extinguishers at a particular temperature that it is compressed. So from there we said if a gas is to be ideal, that gas must be at high temperature and low pressure, Abi. Meaning that if you have a gas at high temperature, that gas will always continue to move at random and will never settle down. And after that, we looked at the general gas laws. And I told you something about absolute zero temperature. What is absolute zero temperature? The temperature at which gaseous molecule cease movement, Abi. And this temperature is what value? So that's 0 Kelvin or minus 273 degrees Celsius, which they can ask you anytime. So now I talked about Boyle's law being inversely related to V, and we saw some kind of relationship. We talked about Charles' law, and we combined Boyle's and Charles, we got our combined gas law. And after that, we talked about Avogadro's law, those are we pay. And after that, we did our ideal gas equation, Abi. And I told you that for ideal gas equation, always note the units of R, Abi. The unit of R is going to tell you the units of other parameters. If R is in atmosphere, dnq per mole per Kelvin, that means that your volume must be in dnq, your pressure must be in atmosphere, and so on and so forth. So now let's move on from here. For an ideal gas, you can have a graph like this when they plot the pressure, if I can still remember, PV against RT, the number of mole. If you have a graph like this, for the compressibility factor, any gas that deviates from ideality, it's said to be a real gas. So if you have a straight line like this without changing its values, then we call it an ideal gas. For anyone that deviates is said to be a real gas. Then another thing you need to take note is that the compressibility factor of an ideal gas is is 1. So you need to take note of that. For 1 mole of a gas, an ideal gas, most of these things are constant. If you look at it, a particular volume occupied can change, but pressure, number of mole, 1 mole, R, temperature, there are things that can be constant. So we got the values of R. So as simple as this formula is, please be careful of the units from what I told you yesterday. There's Gay-Lussac's law too, but because you don't understand basic stoichiometry yet, I might leave the Gay-Lussac's law and move on to the next law. So the next law is known as Dalton's law. So, what else? Temperature, the nature of substance, Abi. So you can't compare your mess to my mess. I'm just joking. Now, substances that would diffuse, you can't compare the rate at which water would diffuse to the rate at which oil would diffuse, Abi. So nature of substance can tell about diffusion. We have different types of perfumes too. Popular wear perfume diffuse faster, while original perfume diffuse slowly and it lasts longer. Whereas somebody So, now from Grant's law of diffusion, that's what we want to focus on. Grant's law of diffusion now states that the rate of diffusion or effusion of a gas, the rate of diffusion or effusion of a gas is inversely proportional. The rate of diffusion or effusion of a gas is inversely proportional to the square roots of the relative molecular mass, or is inversely proportional to the square roots of the density or relative density, as the case may be. The rate of diffusion of a gas is inversely proportional to the square roots of the relative molecular mass or the square roots of the density. And this means that if you want the rate of diffusion to be high, then the molar mass has to be low. That's what inverse relation means. A gas of high molecular mass, a gas of high molecular mass is going to have low rates of diffusion. Please open your brain, there is no time. A gas with high molecular mass is heavy and it's going to take time to diffuse. Shey you get? So a gas of high molecular mass will have low rates of diffusion. Now if I start asking you questions from there now, you want to fair Dalton be Princess of Caribbean. Oh yeah, stand up. Otuwe, stand up, Joe. You and the red boy beside you. Both of you stand up. Yes, you too. Okay, you are green boy. I was talking, you were still funny like a princess. You were not listening, you were just busy gisting. I know you know, come and take marker. Come and teach us Graham's law of diffusion. Then I will never focus on you again in class. Because I know you are Shannon. Oh yeah, what does Graham's law of diffusion state? Oh yeah, both of you look at me. A gas with high molecular mass, what will happen to the rate of diffusion? Will it be higher or lower? A gas with high molecular mass, will it have a high rate of diffusion or low rate of diffusion? I can't hear you. You can see the way I'm shouting at the top of my lungs. Yeah? Low rate of diffusion. Very good, partner. So you have been listening with your friend. So yeah, partner, explain what he has said. What does he mean by it? We have low rate of diffusion. And be fast about it. You are the one talking too much. Explain. What does he mean by that statement? I still said something here. I said if a gas is denser, heavy, before it will disappear, it will take time. That's what I said that here now. Both of you should stand like that. Or you can leave for people to sit since you are not ready. So now, from what we have, if a gas has high molecular mass, it is going to have low rates of diffusion. So in your exam, they will give you different types of gases and ask you to arrange them in order of increasing or decreasing rates of diffusion. And what does that mean? If I have CO2, N2, O2, H2, Cl2, SO2, NH3. All these guys are what? They are gases. They now ask me to arrange them in order of increasing rates of diffusion. That means the one with the highest diffusion will come last. So if I put this gas on the ground now, which one will disappear first? That's what we mean. And CO2, you calculate their molecular mass. What's the molar mass for CO2? Carbon is 12, Abi. They will give you carbon is 12, oxygen is 16, nitrogen is 14, hydrogen is 1, chlorine is 35.5, sulfur is 32, right? So you can do your mathematics. 2 oxygen means 2 times 16, and that's 32. 32 plus 12, that's 44. That means this guy is 44. What is the molecular mass for nitrogen? 28. 14 times 2. Oxygen is what? Hydrogen is what? Chlorine is what? Are you following? SO2 is what? Ammonia is what? That's 14 plus 3, that's 17. So, all of these things, immediately you look at it, you should know. You can't go in the exam and start writing and calculating. You don't have time. So, looking at what we have here, which one do you think we have the highest rates of diffusion? Hydrogen. Is that taken? Because it's the one with the lowest molecular mass. So the higher the molecular mass, the lower the rates of diffusion. So that is one of the things you need to know. So if I'm arranging them, that means the one with the least will come first. So I can say the rate of diffusion of chlorine is less than, right? The rate of diffusion of which one? SO2, right? This one is talking about increasing rates of diffusion, which is going to be less than what? And that will also be less than N2, Abby, less than ammonia, then less than. So that is the arrangement of order of increasing rates of diffusion. Is that taken? So now let's go back to mathematical expression. So if R is inversely related to 1 over root m, then I can say that R is equal to 1 k over root m, Abby, meaning that R root m can be equal to k. So I can say R1 root m1 is equal to R2 root m2. Oftentimes I like to derive it myself. There are a lot of formulas involved here and people make mistakes. But this is what we can do. R1 over R2 can be equal to square root. Sorts are divisible, Abby. Square root of root m1, m2 over m1. So you can derive it yourself. So they can compare two gases, give you their rate of diffusion, ask you to calculate the relative molecular mass for the other. So that is how you do it. Now, another thing is that you need to know that rates is equal to volume all over time. Rates of diffusion is equal to volume over time. So, and that means that R can be equal to V over T. So from here I can say R1 from this place can be equal to V1 over T1. Whereas R2 can be equal to V2 over T2, right? So if I bring it into my equation, I'm going to have V1 over T1 divided by changing to multiplication. That will be T2 over V2 equals root M2 over M1. So you can use this formula if they give you time, they give you molar mass, and they ask you to look for volume of 1. But if the volumes are the same, let's say volume of one gas compared to the other is the same as the volume of the second guy, that means this and this will cancel. Then your formula will be reduced to, so if you have volume to be the same, then that means our formula will be reduced to T2 over T1 equals root M2 over M1. That is another important formula. Now, moving on from here, sorry. What if the time of their diffusion is the same? So if the time of diffusion is same, according to the question, then that means that the time would have gone, then you are going to have V1 over V2 to be equal to root M2 over M1 and separating. So let's check comprehension. Let's look at this question. A gas with molecular mass of 4 times another gas Y, a gas X with molecular mass of 4 times that of gas Y has a volume of 100 cm3. If the time of diffusion of X equals that of Y, determine the volume of Y self-init. A gas X with molecular mass 4 times another gas Y has a volume of 100 cm3. If the time of diffusion of X equals that of Y, determine the volume of Y, for example. So how are we going to do this? So from Graham's law, you can derive your formula. You list out your parameters as a starter. So from what we have here, we have a gas X. You can put that X whenever you are comparing two things. The molecular mass of gas X is 4 times that of gas Y. That means you can say their relative molecular mass. So molecular mass of X is equal to 4 times molecular mass of Y, right? Then let's look at Y. That means what will be the molecular mass of Y? So it will just be its molecular mass. Abi, you can represent it as, let's say, X. You can say, let's say the molecular mass of Y is Y. Then molecular mass of X is going to be what? 4Y. Do you get that? You can represent it with any letter. So that's the first part. Then they now said, has a volume of 100 cm3. Now if I ask you from the statements here, which one has a volume of 100 cm3? Is it X or Y? X. You know, the statement said that a gas X with molecular mass of this as another gas Y then has a volume of 100 cm3. So that means the volume of gas X is going to be 100 cm3. The volume of gas Y is what you are asked to look for, right? Then, if the time of diffusion of X is equal to the time of diffusion of Y, so you can say T of X is equal to what? T of Y. So you don't really need the entire complicated formula. Then you only need this to determine the volume. You have all your parameters now. So what do we do? That's going to be V1 over V2. If you have forgotten this relation, you can derive it. If you get used to it, you see that it's something you can quickly work out yourself. Because one of the mistakes people used to make is that they can go and say V1 over V2 equals root M1 over M2. It's a common mistake, as simple as it looks. That's why if you just know that R is inversely related to this and R is V over T, you can get there yourself. It won't even waste your time. It's not so hard, it's very fast. But if you can cram it, there are a lot of things for you to keep in your brain. So it's not everything you have to cram. So, but if you have practiced often time, you will get used to all of these things. So let's move on. So that is going to be what? Root N2 over M1. It's only when it is time, that's when they are related. But when it is rate and volume, it is R1 over R2 equals root N2 over M1. And if it is volume, it is V1 over V2 equals root N2 over M1. It's only time, it is T1 over T2 equals root M1 over M2. Do you get that? That's when they are related like that. So now, my V1, which is, I can call my V of X now, that is going to be 100 over V2. That is V sub Y. That's what I'm looking for. What's my M2? That's MY. MY is, that's another mistake we should not make. You can start from there. Just say VX, VY, Abi, MY, MX. Shake get. So that I don't, these are simple mistakes people make. Oh. and you will get the answer, and it will be in the option. That's why all these aspects, that's my over 4 my, Abi. My and my can go. Root 1 is 1, Abi. Root 2 is 2. That means that v sub y is going to be what? 200 cm cubed. Is that taken? So God bless you. So let's move on to the next thing. Are you through with the board? That's his law of partial pressure. You are not done. What's the relation between molar mass and vapor density? Molar mass is equal to 2 times vapor density. Please, people make that mistake too. Note this formula that molar mass is equal to 2 times vapor density. So they can give you vapor density in some calculations for you to get the molar mass. Are you there? Let's be fast, please. We don't have time. Kinetic theory is not where we should be spending our time. We still have stoichiometry. We still have oxidation and reduction, acid, base, and salt, electrolysis, chemical kinetics, chemical equilibrium. You see that stoichiometry? I'll just say maybe this Saturday is what we should just start from morning and do only stoichiometry till evening. There are some topics that you can't rush it. Stoichiometry is very simple when they teach you, but sometimes applying it, stoichiometry is very, very simple. Most times too, you don't even see stoichiometry like that in JAMB. Really see. It's basic ones you see. But anytime you want to do electrolysis, there are some topics you can rush in class. Chemical equilibrium, chemical kinetics, thermochemistry. But electrolysis, so we'll put all those ones on Saturday. So maybe this Saturday and next Saturday. Before I start. Are you true? Yeah? So next one, Dalton's law of partial pressure. So Dalton's law of partial pressure. So Dalton's law of partial pressure states that in the mixture of gases that are not chemically combined, in the mixture of gases that are not chemically combined, the total pressure of the gases, is the summation of the individual partial pressure. The total pressure of the gases is the summation of the individual partial pressure. In a mixture of gases that are not chemically combined, the total pressure exerted in the container is the summation of the individual partial pressure. Are you there? So now, what are we saying? If I have a container, and this container contains a gas A, a gas B, and a gas C. We said something the other time that the collision between the gaseous molecules and the walls of their container will give you the pressure, right? At the basic level, this C will continue to collide with the walls. B will continue to collide. C can collide with B. B can collide with C. And collision continues wherever, whenever, wherever. Now, all of their collisions, left and right. We now want to know what is the total pressure here. Dalton's law of partial pressure now states that I need to know the pressure of A, pressure of B, and pressure of C. Now, pressure due to A plus the pressure due to B plus the pressure due to C will give me their total pressure. So, total pressure is given as pressure due to A plus pressure due to B plus pressure due to C. Now, that pressure due to individual is called partial pressure. So, PA, PB, PC are called the partial pressure of A to B and to C, respectively. Are you there? So the partial pressure of A, partial pressure of B, partial pressure of C, respectively. That is what we call the PAPBPC. Am I there? So now, as simple as the formula looks, it still carries children. Let's look at the children attached to the formula for 9 months pregnancy. Partial pressure of A is given as the mole fraction of A multiplied by total pressure. So if you are asked to determine the partial pressure of A, you need to know what we call the mole fraction of A and the total pressure. If you also know the partial pressure of A and you know mole fraction of A, you can also determine the total. If I say what is the fraction of the boys to the girls in this class, that means I'm saying the total number of boys over the total individual, like the boys and the girls. What do I mean? If I say what is the mole fraction of A, mole fraction of A is going to be number of mole of A over number of mole total. Now what does that mean? Number of mole of A over number of mole of A plus number of mole of B plus number of mole of C. That is how you determine mole fractions. Mole fraction of A is going to be, how many gases do I have here? A, B, C, Abby. So if I say what is the fraction of A, it is going to be the number of mole of A over the total number of mole. Shall you get? If I say what is the mole fraction of B, what will it be? Number of mole of B over the total number of mole, right? So I can say partial pressure of B is also equal to mole fraction of B multiplied by P total, right? So meaning that I can say that the mole fraction of B is going to be number of mole of B over number of mole of A plus number of mole of B plus number of mole of C. Are you there? Yes. Then we can also say that the partial pressure of C is also going to be the mole fraction of C multiplied by P total. Then I can say mole fraction of C is also equal to number of mole of C over number of mole total. Then moving on from there, according to Avogadro's, we said that equal volume of gases at the same temperature and pressure will contain the same number of molecules. And what does that mean? That means that I can also determine the mole fraction if I know their volumes. So I can say mole fraction of A can give me the volume of A over volume of A plus volume of B plus volume of C. So you can do for A, for B and C. So these formulas are formulas that have to keep ringing in your brain on the left side of your cerebrum. Now, Are you there? Let me think of a question. Drew. A gas contains nitrogen with mass 14 grams, CO2 with mass 32 grams, and oxygen with mass 16 grams. With mass 16 grams. Determine the partial pressure of oxygen if the total experienced pressure is 4 atmosphere. Full stop. So you have combination of gases, and all of these gases, they have their individual masses, and the mass that you are given, you have to determine the partial pressure of oxygen. Now when you are solving problems, the first thing you really want to know is that what am I asked to look for? That's the first question. Before you go to LLA, you have to first ask yourself, where am I going to? Abi, that's the first question. I am going to LLA. If you are going to LLA, what's the next question you will ask yourself? How do I get there? Abi, how do I get there? That means what route will I take? Is it through Songo? Is it through Mokola? Or is it through LLA road? Then when you decide that it is a LLA road, what are the things that can take me there? That's the next question. So you don't ask for what can take me there when you don't even know where you are going. So where are we going here? LLA weather. From the question, where are we going? They ask us. So the question you will think, that your brain will first think, is that they asked me to calculate partial pressure of oxygen. Abi, then your brain will now think, what are the formulas that I know that can help me to get partial pressure of oxygen? So what is the, if you want to get partial pressure of oxygen, what formula can you use? You can use this formula. Abi, if you know the partial pressure of CO2, if you know the partial pressure of nitrogen, you already know the total pressure, Abi. But do we know the partial pressure of these guys? You don't know. That means this formula is not the best for you. Your brain would have thought about that. Because when you look at the parameters you are given, you would have known. Then the next thing is, I can also get partial pressure of oxygen using this formula, right? So how do I get that partial pressure of oxygen using that formula? Thinking about the parameters, but don't forget, especially if you are a learner, I don't expect a JAMB to be writing some things. At JAMB level, most times you still have almost like 45 minutes left when you are through. To still be going through everything again. So, because it's not everything will be spelling like a baby, especially if you have practiced enough. Some things you would have solved with your eyes, some things you would have determined with your brain. You don't solve with your eye actually, you solve with your brain. But you would have seen with your eye. So, if you now have this, you already know you have mass. Then if I want to get partial pressure of oxygen, I can say I need to know mole fraction of oxygen, Abi. Times P total, Abi. We know P total. We are looking for partial pressure. That means we need to know this. How do we know this? We also know two formulas. Mole fraction of oxygen will give me the number of mole of oxygen over number of mole of oxygen plus number of mole of CO2 plus number of mole of nitrogen. Abi? Then you can see that your problem is solved already. So how do I get number of mole of oxygen? I'm going to use mass of oxygen over molar mass of oxygen. What's the mass of oxygen given? 16 grams. Over mass of oxygen, don't forget it is oxygen molecule. It's a gas. So you are going to have 32. So that's going to be 0.5 mole. Do you agree? What will be the number of mole of nitrogen? That will also be mass of nitrogen that you are given, which is 40 over molar mass of nitrogen, 28. And that should also be 0.5 mole. Are you there? Then what is the next one? Number of mole of CO2. And that's going to be mass of CO2, 32 over 44. What's that? 0.73. So 0.73 mole. Now that you have their number of moles, I think you can calculate the mole fraction now. Can we move on to the next thing? So, from there you can say the mole fraction of oxygen is going to be number of mole of oxygen, that is 0.5 over 0.5 plus 0.5 plus 0.73, and that gives you the mole fraction. What's the answer in total? 0.2. Eh? 0.289. Mole fraction, we have no units. It's a fraction. Mole over mole. Mole will cancel mole. Share again. So now, then I can say the partial pressure of oxygen is going to be mole fraction of oxygen multiplied by the total pressure, and that's going to be 0.289 times, what's that one? 4. And that's going to give you
1.16.
The unit will be atmosphere, Abby. Do you know that from there now, you can also determine other partial pressures? You will just determine one more partial pressure, then now use that to determine the last one. Just let your brain work. A brain that works makes the brain work. Alright, you are the mean. I already said it. The brain that works makes the what? Brain work. If your brain, how do you even survive? You don't know how people used to look at you when you do some things. When you do some things, and people will be looking at you like, and this person is happy. And you will still be happy. You will be happy doing it. And they will be correcting you. But you'll be happy. But everybody will be doing that. So when you get to communities of the brainies, that's when you know how useless you are. This is where. Are you done? So, what else? Can I rub the board? So you need to note something quickly. All of the things you have been doing will be combined in solving questions, solving problems. Notes. Under this topic, whenever the question says that a gas is collected over water, when they tell you that a gas is collected over water, just know that that gas must have been saturated with water vapor pressure. So right, a gas collected over water is saturated with water vapor pressure. A gas collected over water is saturated with water vapor pressure. What does that mean? If you are told that a gas is collected over water, know that the pressure of that gas is not only for that gas. So I'll just do it in a simplified form. If I collect nitrogen, for example, over water, that means that some part of the water would have wet the nitrogen. So I can have a lot of my nitrogen, blah, 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 and then ask me that what is the total pressure here? The total pressure I'm going to have here is going to be pressure due to nitrogen, which is the gas, plus pressure due to water. So you have to be careful of this scenario when they tell you a gas is collected over water. So to get the pressure of the gas, you have to subtract the pressure that they give you, the pressure of water from the pressure they give you. So the general formula is that total pressure is going to be pressure of the gas plus pressure of saturated vapor pressure. Quick question. Then you go for your break and you come back for simple AC cycle. Are you there? A gas X of pressure of 750 millimeter of mercury. A gas X of pressure of 750 millimeter of mercury and volume of 200 cm3. A gas X of pressure of 750 millimeter of mercury and volume of 200 cm3 is collected over water. Is collected over water at 33 degrees Celsius. At 33 degrees Celsius. Are you there? Determine the volume of the gas. Determine the volume of the gas. So, determine the volume of the gas at STP. Determine the volume of the gas at STP If the saturated vapor pressure of water determine the volume of the gas at STP, if the saturated vapor pressure of water is 10 millimeter of mercury. If the saturated vapor pressure of water is 10 millimeter mercury. Full stop. So, in a question like this, the question started with a gas was collected over water, Abi. And when this gas was collected over water, the pressure, what was the pressure given? Now, that 750 millimeter of mercury that you were given, is it the pressure of the gas, or the pressure of water, or the total pressure? Eh? Let's write down. Shall we think fine? You don't look like you are hungry. Yeah. You all look fresh. Yeah. Fresh from the oven. There is nothing that Bright wants to use to tell me that he's hungry. So, Gilead. Go back to Corona. Everybody will grumble. When it is your turn, everybody will grumble. When it is your turn, everybody will walk out. Maybe you can eat. Whatever you do, you will receive it. If you know you cannot receive it, then you genuinely receive it. Even they owe me, I will still say, I will greet them. We are now mates, we are now friends, we are our children. A gas was collected over water, Abi. What is the total pressure? When it was collected over water, be careful of that statement. It can be for the total pressure, or the other side, it can be before. So the total pressure was 750 millimeter of mercury, Abi, when it was collected over water. That means that, what is the pressure of water you were given? 10 millimeter of mercury. That means your P1, pressure of the gas, which is going to be P1, is now going to be your P total is equal to P gas plus P water, Abi. So now, your P gas is going to be P total, 750 minus 10. Do you agree? Yes. And that is going to be 740 millimeter of mercury. And this is going to be your P1. You have settled that one. That will be your P1. Is that taken? Don't make mistakes. What's your V1 now? From the question, what's your V1? 200 CNQ. What's your T1? That's what? 306 Kelvin, Abi. Then you are looking for V2. Under what conditions are you looking for V2? At STP, under standard condition. And for that standard condition, what will be your P2? 760 millimeter of mercury. What will be your T2? 273 Kelvin. Do you get that? If you go and use this 750 without subtracting that of water, you will be wrong, and it will be the option. So anytime they tell you a gas is collected over water, that's how you treat it. But how you treat it now depends on the question's condition. But the way I frame this question, you should have known that it is for the P1. So can you do the rest now? That's going to be P1, V1 over T1 equals P2, V2 over T2. So is there anything left that I've not taught you under kinetic theory? In case I've forgotten. Is there anything left? We have to talk about drift velocity, or what's it called? some other terms like that I know JAMB can ask you, but I'm going to talk about them if I have the time to. So please, within like 2 minutes, let's quickly welcome Gilead. A round of applause for Gilead. So please, before we go for our break, let's welcome Gilead.
Carry on. So you pass. You pass as you carry you. So don't need to be here. Eh, tó bá jẹ́ èmi lè gbé yín. Your life, oh, sorry, your life. Come on, go on, read.
So, ladies and gentlemen, it is what we honor. You will also be honored. When your time comes, work hard. Work hard. So she was one of the students last year. I think her face should be on the board too. So to people that used to say run on par, conform results, thank God you are seeing them every time they come around. So her name is Obadaki Gilead, Balm of Gilead. She is also a nursing student from the University of Ibadan. So Gilead just got nursing, and I would just want her to, I don't really know much of what you're on the university group. So I don't really know much about her story or the challenges she faced or anything that she might have that you might want to learn from. But now you know her, in case you want to study nursing in the University of Ibadan, this is your family member that you will always see when you get there. By that time she'll be in 200 level, and she will tell you how she faced her challenges and how she overcame them. So welcome Gilead to also say one or two things to you people.
Good afternoon, everyone. So like you said, I'm Gilead.
She does not like noise. There are some people that the way they are born, some of you will understand, some of us will know. But let her take her time. So please, let's keep quiet, please.
Okay, so I'm not taking much of your time. I know a lot of people have been coming to motivate you. I know the motivation is working. But for those that are wondering on the cost, that's what I was speaking for. Motivation you guys are hearing. So now nursing in UI is kind of competitive, just as medicine. So I have 291, very small JAMB score, and my post-UTME score was 71. So like basically, if you can read, you should be able to do well in UI post-UTME. And then for those that register like the first week of JAMB registration, you might be lucky enough and you'll be in the first batch of those that write UI exam. Just know that your questions will be past questions. For that first day like this, my enjoyment is my day. I wrote my own on Tuesday and it was very tough. So we came out of the exam like this, all of us were just looking at studio. We don't say it will be fine. And we thank God it was fine.
The spirit of
Okay, so that's basically all. Read. Everything is still reading. solve past questions. The major use of those past questions is to broaden your knowledge and all for the way different topics can be asked. You can finish your past questions, then there should not be any question that you'll be able to solve this kind. So it will be fine.
So, during post-UTME, to those of you going to different universities, we are still going to talk about it. I'm going to tell you how we are going to do it, the orientation and what you need to focus on for each school. We are still going to talk about it. There's a systematic ways in which most of those questions are set. If you follow instructions, you will do well. But if you decide to choose your own lane, you will still do well, however. So, Gilead.
And another thing I would like to add is, for those that are Christians, please, let's try to always pray. It's only God that can help you. It's not by JAMB score, it's just by the grace of God. You guys just try to pray. If you remove God out of the picture, I'm sorry, there's no way you can just do well. Always add God to the picture. And then primary usually do these 400 questions for each subject, like 1 week to your JAMB or 4 days to your JAMB. Trying to solve those questions, it really helps for my JAMB.
So those questions are 200 for each. I told you about it this morning, that we used to do it. And for UI, we'll still talk about everything, so in order not to waste our time. So, but how many times did you write down? Twice. In primers. You wrote it twice. Was your second? What did you score? 267. So you moved from 267 to 291. What time did you join primers? January. So you can see the system, the way it works. She had 267 from her previous school. She joined primary middle of January and she wrote JAMB again and she had 291 and her post-UTME and she gained admission. So you have had a lot of people came and said they did it 5 times, 7 times. You don't have to do it 5 times, 7 times. But everything still depends on other factors. It depends on other factors. So it is not your fault at times. So don't, I know she'll say, wow, when she had 71, she had 70, and she had a lot of things to also combine. If she had that 71, she would have also been nursing by now. So, but she was also already in UI by that time. She was facing UI exam and a whole lot for combined. So there are different factors that can affect admission and law. You had when Kinetic came yesterday, Salam missed admission. So that we can vote for break. Salam missed admission by just 0.7 and that made it to wait another year. And the following year now beats the cutoff with almost 10 marks. So it all depends. Just continue to pray. There's nothing you can do beside God. And that is what she has said. Put your life and your preparation in God's hand. Now, all of you should please notice all the information. You know, most people that be coming, they will tell you that whatever they tell you in primers, whatever this tell you, whatever this tell you that you should do. Fine. To me, I know that sometimes I might check 1 or 2 things, and when I come to class, I'll say it. I might not even know how it works. But whatever research I do, I come back to tell the class on how it will go. So please, as much as possible, you know, a lot of things I was saying, teaching this morning, it's not about materials, it's not about textbooks, it's not about notes. Sometimes one little information can go a long way to make the difference. If she had scored 70, I'm not sure she might have beaten the cutoff, and she might have had to write another JAMB again. So work hard. Don't neglect basic information. Simple thing that you need to work on. Please, don't just neglect it. You might not read so hard. She came to primary at middle of January, almost, and we started class since maybe August. For that of last year, we started August the previous year. And she, so you coming now, it does not mean you can do well. Just do the right thing. Pick the right friends. I know she has some couple of friends. They used to live together then. So pick the right friends, work with them, and I know God will help all of you. So please, a round of applause for Gilead once again. So, Gilead, as you are going to UI, we have started out to classes. We have not been on the basis. You are doing maths too. Maths 1. Survive that. So, as much as the dollars will take children maths 1, so you should have been taught. But as much as possible, as you are going to school, please work hard. These days now, I've been hearing a lot of news that makes me sad about some of our students on campus. There are some courses that when you are doing them, they can, if you fail some courses, you're automatically out of that department. Now imagine how hard. Hello. You people will not get the right information now. Things that will cost you like 4 or 5 years of your life. You are not listening now. I have some people that are facing some terrible challenges that I'm not happy about. And they were people that were serious when they were in this place. And some of them now, after like 1 or 2 years, they failed some courses. And failing those courses, they cannot progress. They will be dropped out of school. Now imagine you worked extremely hard to study nursing. You now went to fail one course. And that course is free. And the moment you fail that course, you're automatically out. And at the end of the day, some people even fail more than one. In medicine, I have many of our classmates that failed physics. In pharmacy, I have people that failed physics. In that same nursing, we have, please. And now, all I can do is just encourage them and advise them to go for JAMB again. Because, yes, I have a lecturer of mine that spent 16 years on campus. And he became a lecturer. He should have been a prof now. He was first in medicine and all of those things. They sent him away. You don't know the challenges people are facing in all of this field. Many of you just want to go there, just want to go, and you are not ready for challenges. Ordinary JAMB is bringing you like this. You are shaking. You don't know. We don't pray that you face challenges that will be beyond your power. But most of these things, they don't joke with them. If you are in pharmacy, they don't joke with errors. They don't. In medicine, they don't joke with errors. You cannot kill a patient. So all of these things are very important, especially if you are in health line. And that's why even you now, at this point, for you to get admission to those courses, you are likely to face some bit of challenges. If you give up on those challenges now, you are not the type that is wanted in that field. So please, as I'm begging Gilead now, that she should please be serious with the courses when she gets there. There are a lot of these courses that, while some of us are bothered about 5.0, some people are bothered about, let me shall pass 1.0. If you go below 1, you're out of the department already, and people are below 1. You will see they will release Book of Life. Maybe they have even released it already. They released PGO because Yola was calling me the other time. So the thing is that they will release Book of Life, and when they release Book of Life, that's everybody in this place, all your classmates, all your friends. That's one thing about UI. UI does not cover shame. They don't cover shame. All the things you do in your part 1, all your total results and your CGPA, they will release it to the whole world. So your parents can see it. In OAU, those days, OAU will release your results. Most of our results used to be on portal. Your CGPA will be on portal. So you can even be on campus for 5 years, and a lot of us will not know that you have been dropped out. You might not know. When UI, one boy last year now, they were saying, but this boy was the best graduating student in their secondary school. He was brilliant. How did the GP drop to below 1.0? And that boy was sent out of pharmacy because he failed this thing and that. I never knew the boy, but I had a lot of people talking about the boy. So it's the same thing. God will help all of you. It is not just to work hard at this level. This level is a step. It's just the minimum step. You will work hard. You will get the course. When you get those courses, when you get there, you can't afford to fail a course in 100 level. You fail a course, you fail 2 courses, depending on your department, you are going to go and prepare for JAMB again. And one of the things I think has not confirmed the information is that if UI especially is the one I had, if a university is the one that sends you out themselves, I have people that OAU sent out and they still came back after some years. If they send you out, you can't come back to that school. Yes. So there are sometimes that people will just advise to withdraw. So you will just withdraw yourself. A lot of things are there. If you see people with 5.0, 4.9, 4 point something, you know that those people they are reading, they are working, they are smart. So it's not that easy. God will help all of you. So you can go for your break. God bless you. Yeah.